You're going to learn about statistics. With statistics, you measure things. You measure the x variable and the y variable. So measurement is extremely important. We'll talk a bit about the measurement process. When you're measuring something, you want to do that accurately. You want that measurement to be valid, that is, truthfully represent what you think it measures, and you want it to be reliable. You want it to be consistent from time to time. So validity is the most important concept. It's made up of relevance and reliability. So for example, skin fold measures are valid estimates of subcutaneous fat. Why? Because they can be quite reliable, consistent across time, consistent across testers, and it is relevant. It measures subcutaneous fat. Regardless of whether you're assessing the cognitive domain, the psychomotor domain, or the affective domain, you want your measures to reflect reliability and validity. So let's talk briefly about the measurement process.
What is measurement? Measurement is the process of assigning some symbol, and this is almost always a number, according to some set of rules to reflect the amount of a characteristic that something possesses. That something is usually a subject in a study. It could be a person or it could be an animal. Now this may involve just categorizing events, which is called a qualitative measurement. You either belong to group A or group B. You may be a male or a female. Or it may involve using numbers to characterize the amount of some characteristic, which is a quantitative measurement, such as you are 5 feet 7 inches tall and somebody else is 6 feet 1 inch tall.
There are essentially 4 steps to the process of measurement.
The first step is identification and definition of the object or concept to be measured. Who is it you're measuring? And then you want to identify and define the standard to which the object will be compared. Are you going to use a ruler? Are you going to use a thermometer? Where is the scale coming from that you're going to use for measurement? The third step is to compare the object that's been measured to the standard that you've used in the process. Fourth step is a quantitative statement made about the relationship between the object and the concept and standard. So does the person exceed some level of measurement? Is the person over 6 feet or under 6 feet?
We'll talk about 4 levels of measurement. Not all numbers are the same when you measure something. The lowest level of the measurement scale is nominal. Nominal simply means the class of a nominal variable would be gender. You're either a male or a female. You're a 1 or a 2. You're a 0 or a 7. It makes no difference what those numbers are. They simply differentiate people based upon the categorization into which they fall. You're in the experimental group or the control group. You're a 0 or a 1. So oftentimes people talk about the frequency count under nominal variables.
Second level of measurement is ordinal. It tells you more than the nominal scale. It doesn't just say that you're in this group or that group. It is able to order people or rank people.
The third and fourth levels can be combined to be called continuous measures. The third measure is intervally scaled measures, which talks about differences between points. For example, the difference between 40 degrees and 20 degrees is 20 degrees. The difference between 40 degrees and 60 degrees is 20 degrees. But the 0 has been arbitrarily chosen. So you can't say that 60 degrees is twice as hot as 30 degrees is. Similarly, whenever you have a test score that results from a class examination, simply because one person got twice as many right as another person, you can't say that person knows twice as much knowledge or they're twice as smart. You can simply say that the difference between 40 and a 60 is the same as the difference between a 40 and a 20, because you're talking about here an interval measure, something like knowledge, or for example, strength. On the other hand, when you get to the highest level of measurement, the ratio scale,
which does have a 0 point, you now can make statements about twice as much and 3 times as much or half as much.
Return to our example about strength or achievement. A person who gets 7 right on an exam and another person who gets 14 right on an exam, the person who got 14 right actually achieved twice as many as the person who got 7. Because 0 correct means there's an absolute number gotten correct. That is 0. With regard to strength, if you think about strength, how many reps can one do? One person does 30 reps, another person does 15 reps. The person who does 30 does twice as many reps. But are they actually twice as strong? No, because they might be lifting different amounts of weight.
Notice that the higher levels of measurement contain all the characteristics of those that fall below them. So that means that you can take a ratio scale and change it to an interval scale or to an ordinal scale or to a nominal scale. But you can't go the other direction. There's no way, if all you have is ordinal data, to make it into ratio data or interval data.
If you did change variables into different levels of scale, you lose some information. Importantly to our text, each of the procedures that we talk about in statistics will necessarily require data to either be nominal, ordinal, interval, or ratio. That will help you to determine which statistical procedure you'll use.
So you will have to know how to identify what level of measurement a variable has.